We've all looked up at the stars and dreamed of traveling between them, right? But the universe is just mind-bogglingly huge. It feels impossible. But what if it's not? For forever, interstellar travel was purely science fiction. But today, we're going to see how that sci-fi dream is getting weirdly close to quantum reality. Let's dive in.
Okay, so first things first, let's just wrap our heads around the problem. The universe is ridiculously big, and there's this cosmic speed limit, the speed of light, that we just can't break. So how could we ever hope to zip between solar systems in a single lifetime? Well, science fiction has an answer for that, but it's a popular one that's, completely wrong.
And that's the big question, right? If we can't go faster than light, is there a loophole? Can we cheat the system? Is there some kind of cosmic shortcut that could actually make this happen?
And of course, pop culture loves this idea of a shortcut. I mean, you see it everywhere, right? In shows like Stranger Things, in countless blockbuster movies, black holes are always the go-to gateway. They're these mysterious portals to other places, other dimensions. It's a really cool idea, for sure. But yeah, physicists have some bad news for us.
So here's the deal. A black hole is a terrible travel agent. There are at least 3, let's call them, fatal flaws. First, it's a one-way ticket. The event horizon lets you in, but absolutely nothing, not even light, gets back out. Second, even if you could somehow find an exit, it would be so unstable it would slam shut faster than you could blink. And finally, the one everyone's heard of, spaghettification. The gravity is so intense it would literally stretch you out like a piece of spaghetti long before you got anywhere near the center. Not a great way to go. Okay, so black holes are a no-go. What's left? Well, this is where the theory gets really cool. Physicists have a totally different kind of shortcut in mind, one that, at least on paper, might actually work, and that's the wormhole. Yeah, this image pretty much nails the concept. Think of it like this. The original idea was called an Einstein-Rosen bridge. A wormhole is basically a tunnel through spacetime itself. So instead of taking the long road across the surface of the universe, you just punch a hole and cut right through the middle. A true shortcut. And this diagram kind of shows you the anatomy of a wormhole. You've got 2 mouths in totally different parts of spacetime, and they're connected by this central tunnel. Now, the most important part, the real choke point, is that narrowest section in the middle. Physicists call it the throat, and getting through that throat safely, that's the whole ballgame.
But here's the thing, not all wormholes are the same. That original Einstein-Rosen bridge idea, it was just as deadly as a black hole. It would collapse faster than light could get through it and just crush you. It wasn't until the 80s that 2 physicists, Morris and Thorne, came along and designed a new type of wormhole on paper, one that was stable, one you could actually travel through, one you could survive.
A stable, traversable wormhole. It sounds perfect, right? So, what's the catch? I mean, why aren't we building these things? Well, it turns out that holding a tunnel open in the very fabric of spacetime requires an impossible ingredient. I mean, just think about it. Gravity is always pulling. It wants to crush everything. It wants to grab the walls of that tunnel and slam them shut. So what on earth could you use to prop open the throat of a wormhole? What could possibly be strong enough to fight against the crushing force of gravity itself? The answer, it turns out, is also the single biggest reason we can't build one. To hold that wormhole open, physicists are pretty sure you'd need something called exotic matter. So what is exotic matter? Well, it's stuff with properties unlike anything we have ever seen in the universe. Specifically, it has to have negative energy density. Now, what does that even mean? The simplest way to think about it is this. Normal matter and energy create gravity that pulls everything together. Exotic matter would do the opposite. It would create a kind of anti-gravity that pushes everything apart. It's literally the only thing that could prop the walls of the wormhole open. But let's say we could get our hands on some of this exotic matter. Keeping the wormhole open is just the start. If we could actually build one of these things, we might accidentally create something even crazier, a time machine. And as soon as you start talking about time travel, you run into all sorts of brain-melting paradoxes. Okay, let's walk through the classic example. You've probably heard this one. Imagine you build a wormhole that connects to just 1 minute in the past. You step through it, you see your past self about to open the wormhole for the first time. But what if you stop yourself? Well, then the tunnel was never opened, which means how did you get there to stop yourself in the first place? It just completely breaks logic. So, does the universe even allow these paradoxes to happen? The late, great Stephen Hawking had a brilliant answer for this. He basically said the universe has a built-in safety switch. He used this amazing analogy of audio feedback at a rock concert. You know that high-pitched squeal? He said a tiny bit of radiation would enter the wormhole, travel to the past, and come out to re-enter its own past over and over, creating this insane feedback loop of energy that would just, poof, instantly destroy the wormhole. Paradox avoided.
All right, so it seems like these giant spaceship-sized wormholes are a dead end. You need impossible matter to build them, and they'd probably blow up if you tried to turn them into a time machine. It was looking like they were going to stay in science fiction forever. But then, a completely radical new idea came out of the super weird world of quantum physics. It's this mind-bending idea called the ER equals EPR conjecture. And it basically says that two totally separate, really weird ideas in physics are actually the same thing. Okay, so EPR is for quantum entanglement. That's Einstein's spooky action at a distance, where two particles are linked no matter how far apart they are. And ER stands for Einstein-Rosen bridge, which is just the technical name for a wormhole. This theory suggests that every single pair of entangled particles is secretly connected by its own tiny microscopic wormhole. Wild, right?
And this is where you have to reset your brain, because we are not talking about giant tunnels for spaceships anymore. These quantum wormholes are microscopic, totally invisible, and they're not held open by some crazy exotic matter. They're created by the active entanglement itself. They don't connect distant galaxies. They just connect the two entangled particles.
Okay, this idea is incredible, but it also sounds untestable, right? I mean, how could you possibly find evidence for a microscopic wormhole connecting two tiny particles? Well, the answer might be hiding in plain sight, inside the most basic, most well-studied object in the entire universe, a simple hydrogen atom.
All right, hang with me. The logic goes like this. A hydrogen atom is just a proton and an electron. And guess what? They're naturally entangled. So if ER equals EPR is true, there should be a tiny wormhole connecting them. Now here's the clever part. What if a tiny, tiny fraction of the electron's electric field could leak through that wormhole? If it did, it would ever so slightly weaken the connection between the proton and electron. And that tiny change in energy is something we could actually, theoretically, measure.
And where would we look for that change? Well, this tiny energy shift would show up as a ridiculously small error in one of the most important signals in all of astronomy, the famous 21-centimeter line of hydrogen. This is the radio signal that astronomers use to map out the entire universe. So, if ER equals EPR is real, there should be a tiny little glitch in that signal.
So, the big question, did they find it? Well, physicists crunched the numbers from super precise measurements of the hydrogen atom, and what they found was nothing. Well, not exactly nothing. They found that if this wormhole effect exists, it has to be incredibly, unbelievably small, like weaker than 1 part in a billion. So if the electron's field is leaking through a wormhole, it's a nearly undetectable trickle.
Which leaves us with this really profound final thought. Maybe our whole dream of building giant bridges to cross the stars was looking in the wrong place. What if the most important bridges in the universe aren't giant tunnels for spaceships, but an infinite network of microscopic tunnels woven into the very quantum fabric of reality itself, connecting every single entangled particle that has ever existed? What do you think about that?